And let go of the mouse. All right. Well, welcome back. Are we talking during class already?
I told you we're going to have separate.
Well, welcome back to our Math Homeschool Connection. I really appreciate you being here. Again, this workshop is to just help you to guide you in reviewing math tests and preparing for different tests that will be coming up. The cool thing about this one is we haven't actually even started fractions in class yet. So rather than the last one, we were doing more review of old material. We're kind of previewing new material this time, so you'll be better prepared to help the students as they're progressing through the fractions unit, which will be starting on Friday. And so you'll be one step ahead of them pretty much. Again, feel free to take notes. I did provide the paper copy, and you can also follow along in your Chromebook. If you want it full screen, like how I have it, all you have to do in the upper right corner, it says present, so you can press present, or you can just follow along with the arrow keys. If you're following along in full screen, you just need to click for it to progress the slides, but it's your personal choice. We're going to be going over concepts and test questions in general. Again, if you have any questions about your specific child, feel free to see me afterwards. And at the end, we're going to actually review how to use IXL, how you can make sure your child is practicing what they need to be practicing on IXL versus just going on and doing basic facts overall. First thing we're going to start with is our benchmark review. Here, you can get the papers. I'm going to go through the benchmark review, show you what we took the benchmark a couple weeks ago. A word of note before Mrs. Burkansi's out, the scores aren't great. I will be blunt about that. We had taken that before we were done with long division. So this was not a grade in the grade book or anything, but I just want you to know, don't get alarmed, because we had started long division a couple days and there were a number of questions about long division. Because we had spent so much time on the last time on how we did discuss last time, they were a little behind in long division. So that being said, we have worked extensively on long division in the past couple of weeks since we took the benchmark till now. We'll have a test on Thursday, and I'm expecting that we'll do very well. So if we go through this, one thing that I want to point out, that the benchmarks were taken on computers, just like they're going to be taking their SOLs on computers, and they actually did the work on the papers. Mrs. Burke she's bringing around this paper. The printed paper has the item breakdown. So if it has in the column the total, it has 100. That means they got the question correct. If it has a 0, it means they got it wrong. So the other papers that she'll be bringing around, which should be part of your score sheet, are the actual work. I don't have copies of the actual paper right now, but this will kind of guide what the questions look like. So this is the work that your child did, and the printed paper is how they did. So just to go through the questions, we can see what I did on here was I took the questions and I aligned them to what skill they were. So you can kind of see it better than, you can see this middle section, which is the red and orange. Those were all division problems. So we can see class-wide, we did not do great on long division at that point because we hadn't gotten there quite yet. On the things that we had done was we did a lot of multiplication in supervisory. We can see there's a 91% accuracy there, 91, 82, 86, 78, 100, 91. So they did very well on multiplication, which was one of our really big skills in second advisory. Like I said, division, we were still working on that, but we have worked on that, and for the most part, most students have mastered that at this point. Some concepts to continue reviewing is estimation, and especially elapsed time. If we see questions 22, 23, and 25 were elapsed time questions, and each one of those were less than 50% of the class had gotten that correctly. One of those, it showed that they had to identify what was the clock said, what time it was, and then do timeline. One was just timeline, and one was the count back method. So this just kind of sees what skills that each thing had. This kind of shows what the students class-wide had worked on and need some extra work on. And the paper that I printed for you is what your student specifically needs to work on. Some things that they really need to work on that they should have done pretty well by now is patterns. And by patterns, what I mean is pretty much just reading what the question is asking. This one says the pattern continues in the same way. Well, will be the seventh number in the pattern. So the first step is they have to identify what the pattern actually is. I believe in this one it's at 9. So it stops at five numbers, and it gives them 6. And if you add 9 to 50, it'll give you 59. But it's asking for the seventh number. They will do that on the SOLs. They will do that on the benchmarks, that kind of thing. So they need to make sure that they're identifying that they are looking for the seventh number, not necessarily the next number. Another thing that they need to work on is a multi-step problem. One of the last questions was a multi-step problem where it said that there are 8 people at a party. Each person's going to eat 8 slices of pizza, or 3 slices of pizza. A pizza has 10 slices. How many pizzas do they need? So they had to figure out how many slices they need, then divide that by pizzas, and then had to round up because you can't order just part of a pizza. One thing that some students did really well, and some students kind of just went way over the top. They did the multiplication step and said that there were 8 pieces or 8 people, and each needed 3 slices. So they said they needed 24 pizzas. And after I told them that they had made a mistake, I just asked them, think about that reasonably. There's 8 people. You're ordering 24 pizzas. Does that really make sense? You're not going to order 24 pizzas for that many people. So then they kind of thought, they're like, oh, I did need to go another step. But they had already kind of finalized their answer at that point. So just make sure they're doing a multi-step problem. One thing I just attached one here. This one, it gives them a table and says which was the closest to the difference between the total number of miles that the family traveled on day 1 and 2 combined and the total number of miles traveled on day 3. So this is actually a 3-step problem because what they have to do is they have to add days 1 and 2 and then subtract after days 3 and then round them. So that's a lot of steps they actually have to go through before they get their answer. And I'm willing to bet that all those answers right there would be if you stopped too early or you added wrong. So just make sure you're working on multi-step problems. And like I said, just to check your student sheet for specific problems they had. If they had a lot wrong in the division problem, I'm okay with that for right now because we had just started that and hadn't quite mastered that. If on Thursday they still have problems, then we can keep remediating that. I'm more concerned with if they had any issues with the multiplication, especially for the last time, anything about estimation. So those are just a quick benchmark review. Again, feel free to ask me questions afterwards. But we're going to get moving on to focus overnight. With the focus overnight is fractions. Fractions is our biggest focus in third advisory, so we have to split this between 2 nights. Tonight is kind of getting the overview of the concepts about fraction, and then 2 weeks from now when we reconvene, it'll be more how to add and subtract with fractions, compare fractions, and order fractions. But kind of need the basis of all that stuff before we can move on to, or we need the basis of this stuff before we can move on to it. So the fractions, the actual SO and L number for that is 4.2. That's just kind of helpful if you want to go on the Virginia Department of Education website. You can read exactly what they are expected to be able to do by the time they have mastered this standard. And the one understanding for fractions that they need to understand that it represents equal part of whole. And we do, in 4th grade, we do fractions starting with halves all the way to 12s. We don't go any bigger, and we very rarely will actually work with 7s, 9s, and 11s because those don't divide evenly. They will see that eventually, but those are kind of phased out as we get into the computation. It is very much related to decimals, which we had done in the first advisory. So we try to relate the fraction to the decimals to try to get them to know that we already have kind of covered this concept in general about it's less than a whole and it's equal part of a whole, but just to make sure that they're kind of bringing those 2 pieces apart together. So fractions in 4th grade are going to be shown through 4 different ways. It's going to be shown through area models. This is the pretty much traditional thing when you think of fractions, that it has a bunch of boxes or circles or circle cut into a bunch of parts. They have to say that there are 4 9s shaded. So that's pretty much the most basic one they're going to see. Generally speaking, they have that kind of stuff in 3rd grade and simpler form in lower grade, so they're not going to make too many mistakes with that. Another version is called set models. Again, this is pretty much basic because they've seen this kind of thing. It'll give them a group of boxes. In this case, it's triangles. They have 2 of them shaded, so they know that 2/4 are shaded or 1/2. So they can do that with. I know I've seen on the SOLs they have pictures of candles that are burning and not burning. They have pictures of a group of children, and it's boys and girls, that kind of stuff.
What's the website that you say?
The Virginia Department of Education If you go on my website under resources, you can get to it through there. These are the two kind of newer ones they're going to see in fourth grade, especially this, what's called that they need to recognize that a fraction is represented as a division statement. That 2/5 is actually read as 2 divided by 5. One of the most common mistakes, or moving to the common mistakes last year that they made, was they would reverse that division statement. They knew that the 2 and the 5 were important, not necessarily sure what order to go in. And then this other thing, measurement models. This is basically fractions on a number line, and they did this with decimals. And what they need to do basically here is just count up all of the lines and figure out where it is. The biggest mistake they make here is they don't count the 1 as 12/12ths. They think that it's actually only out of 11 because there's only 11 little lines. They need to remember that 12/12 represents 1 whole. So, like I said, these are preview things, and hopefully this night will help us get a leg up on fractions. So, like I said, common mistakes can go from anything from as simple as not counting the total amount or amount shaded properly. If you could use the arrow to go back. Go back. All right. So, as simple as just not counting how many blocks are. That's really kind of an inexcusable mistake because there's really no reason to not be able to count. But just rushing through things, that's going to be the simplest problem, and also probably the simplest problem to correct, because all they're going to have to do is count again. Next, go back to what I had. All right. Like I said, reversing the division statement, these are two ways that they're going to see it represented on this walls, and says which fraction represents 4 divided by 5. So what it has here is 5/4 and 4/5. Those ones are, they would have added 4 and 5 and then tried to divide them. So they have to realize that 4 divided by 5 isn't 5 divided by 4. And I've noticed when we're doing long division, a lot of times if it's the problem is like 525 divided by 5, they'll say 5 divided by 525. And I try to get them to realize dividing that is a lot smaller than that. So that's something that you can work on as we start this. That's division statement is probably going to be one of the very first things we start on Friday when we start fractions. So starting on Friday, you can just ask them if they work on fractions that day. We don't make it every math group every day, but if they did, you just give them a fraction and say, how would I read this fraction? And they'll probably say 4/5, and you said, what if I wanted this read as a division problem? All you have to say is 4 divided by 5, and if they mix it up, you just kind of talk them through it, and it's, that they will eventually get it. And the other one is it'll give them the fraction, and they just have to choose how you would actually read that. One of the biggest mistakes with this particular SOL strand is that they might not understand that a bigger denominator actually means a smaller piece. They might see 1/5 and 1/2 and know, oh, 5 is bigger than 2. I think 1/5 is bigger than 1/2. But one thing I will start doing on Fridays, I have little fraction models, and I'll actually have them hold 1/5 and 1/2 and see they would have a much smaller piece than if they had 1/2. So that's kind of reverses everything they know about numbers. That with fractions, a bigger number on the denominator actually means a smaller piece of the whole overall. All right, so ways to practice these basic concepts about fractions. IXL, the whole Q strand is fractions. You can really just ask them about fractions in everyday life. Like if I said how many family members are girls in your family? If there's one out of 4. However many people are in your family. You could say I went to the homeschool connection night and there were 13 people there, and and how many of them were boys, men, whatever you want to say. That's just a really way to kind of pop fractions in here and there. You can also get 12 different color tokens or little small toys or coins, anything like that. Kind of put an amount of them. You don't have to put all 12 down. You can just put a certain amount and ask how many of these are nickels, how many of these are quarters. Give it to me in a fraction. That's just going to help with the set models. Another thing you can do is just draw a line on a ruler. The ruler, each inch would represent a 1/12, and just ask, what would this be? If assuming that the ruler is one whole. So it's 5/12. You can do that, and you can always change. You could switch it to the centimeter side, and then you can just make sure that they understand what you're counting as 1 whole at that point. So this overall stuff with fractions is where they make a lot of their mistakes. It's as we progress through fractions. But the division statement I know was, and the number lines were two big things that they struggled with last year. So another thing that they are going to have to do with fractions that gets a little bit more intensive is they're going to have to be able to do the fractions and the decimal equivalents. I would really like the fractions and the decimals to be taught together, because then I could kind of relate them a little bit, but it's no big deal, we can always backtrack. So what it will happen is when they're given a model, students will write fraction equivalents. And like I said, division or decimals were taught in the first advisory. The nice thing for this, it's only focused on halves, fourths, fifths, and tenths, so that gives them a little bit less to worry about. The reason I listed these is it's going to make their lives so much easier if they simply just memorize these equivalencies. If they memorize that 1/2 is 0.5, 1/4 is 0.12 or 0.25, and 1/5 is 0.2, and 1/10, which just be like shown on the screen, is just 0.1. That's just going to make their life so much easier, because they're going to have to, all they have to do is now, oh, I have 3/4, so 1/4 is 0.25, just add 3 of those. Because if they see like 1/2, and it'll say, what's this fraction, and it'll also want it in decimal. So 1/2, they'll have 1/2 as an answer. They also have 0.2, but they want 0.5. So really just getting them to memorize those is going to make their lives so much easier. So common mistakes, I saw this a lot on when we were practicing for as well as last year, this question in particular. They focus either on just the fraction or the decimal and not both. So in this question, it wants them to tell what the fraction and the decimal are equivalent to model X. So what they might do is they see that's 2/10 here, because there are 10 total and 2 of them are shaded in. So then when they come over to their answers, they see 2/10 and circle that because they see 2/10. But it's asking both fraction and decimal. And the decimal that they have there is 2 and 1/10, which is 2 wholes and then 1/10. So then what they do here is they see 2/10 there, but they see the 1/5. That gets into having to reduce the fractions, which is something else we'll be going through tonight. But it's kind of getting them to recognize going back and forth with the decimal and the fractions. It's just very important for them to realize that you need to look at both answers, especially in these kind of questions. It's the same thing over here. Which decimal and fraction are represented in model 2. And it shows here that 1/5 is shaded in. And so right here has 1/5 and 0.1, but that's not correct because 0.1 is 1/10. But then here it has 1/10, and they see one thing, and they know that it's supposed to be 1/10, so they make mistakes there.
So for the example of the answer being B, as soon as they start getting into fractions where there is the option to reduce it, are you going to immediately say, look, don't just put 2/10, this is really 1/5?
Right, yeah.
And that's immediately going to introduce that?
Yeah,
or are they going to start from...
Basically the order I'm going with tonight is the exact order I'm going to teach. So like Friday, I'll start with the overview, and then we'll get into like a least common multiple and base common factor. And then they're going to start reducing before they do pretty much anything else with. They're going to be able to identify fractions, and then reducing is going to come pretty much right after. Because I'll be honest, I made that mistake last year. I tried to introduce reducing after everything, and they got so hung up on just getting an answer and not reducing it. So I'm going to introduce that earlier this year, so they always know to look for if it's possible to reduce. Because not every fraction can reduce, but I'm going to teach them tips of how they can reduce, and that's I think that's it. So I think that's something that but yeah, they will learn how to reduce probably within the next week and a half. It depends on snow and all that kind of stuff. But yeah, reducing is definitely going to be one of the very first fractional things we're talking about. So way to practice the decimal and fraction equivalents. I actually had to kind of search because this particular skill was actually lumped in with the decimals rather than the fraction skills. So it's U2 and U8 is going to do that. U is all of the decimal stuff. So it's kind of admittedly hard for me to look through that to find exactly what they needed to use. But U2 and U8 are going to practice that specific skill. And another thing is you can just simply create your own fraction block. Just get a piece of cardboard, divide it into 10 pieces, 8 pieces, however many you want, and have them. And I would do that on a whiteboard so then you can erase it. And then you can have them write both the fraction and the decimal representations of both. It's a pretty straightforward way for them to practice that. All right, this starts getting into the reducing fractions and then eventually making equivalent fractions, which is kind of what we will go for with next time, because they need to be able to reduce fractions and they need pretty much equivalent fractions for the rest of everything with fractions. The first thing is least common multiple, and the multiple is basically just the products or the answers in multiplication facts. The word multiple really scares them because it sounds like a new word, but when I just tell them that it's just the answer to all of your basic fact problems, I'm like, oh, I can do that, I can count by, skip count, whatever. To find the least common multiple or just any multiples in general, all they need to do is list all the products. I tell them to pretty much go through the 12s because some questions are going to need the least common multiple. Some questions, they're going to need just all the multiples that they can get between those numbers. There's going to be always a maximum of 3 numbers and 2 numbers. And as they get into upper grades, they're going to have more numbers. But I tell them just as a habit to list from 1 all the way through 12, because that's just going to kind of guarantee that they're going to encompass all the things. If they're really good with their basic facts, that's going to not take them not very long at all. If they're not great with their basic facts, they really need to practice that. Like I've been saying all year, they really need that basic facts to be best proficient with this. And then when they find the smallest match, and I'll show you that in a second, that's called the least common multiple. Least common multiple is used for creating equivalent fractions, which is a very important skill that we'll get into, and also just adding fractions with unlike the numbers. We're not going to get into those 2 concepts this week because that takes a little bit more time, and I don't have quite all that time to do reducing and that. But it's just, this is a pretty good thing that they need to know how to do. It's one of the first things that they're going to learn with fractions. So to find least common multiple, all you do is, like I said, if the numbers given are 2, 3, and 6, all you do is you list out all the products, all the multiples of the basic facts. So I just count by 2s up to 24. With 2s, you can pretty much count indefinitely because it's easy to just keep going with 2s. Then you do it for all the 3s, all the 6s. Like I said, I always go to 12. The least common multiple, and then you just go back through and you just look for the matches. So they all had a 6 in common, they had 12 in common, they all had 18 in common, so on and so forth. The reason that works out so nicely is because 2 and 6 are factors of, or 2 and 3 are factors of 6, so everything 6 has 2 and 3 on it. So the least common multiple in this case is the 6 because that is the smallest number that they have in common. If the question's asking for least common multiple, they would want 6. If it's asking for which numbers are common multiple, and I'm going to show you an example of what that's going to look like. That's why they would need to list them all. Can you hit escape real quick, please? All right. So I have an example here. If I'd like for you to follow along on whiteboard. If you want to, if you don't want to, that's fine. So the numbers given are 3, 6, and 5, and they're going to be tasked with finding either all the multiples or just the least common multiple. So the first thing I tell them to do is just list the numbers simply like so. And then what I do is I just tell them to basically say their basic facts in their head. So I will have them say 3 times 1 is 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, and 36. I haven't stopped at 36 because that's 12. Then they do the same thing with the next number. So they'll start the 5s, 3s, 2s, 3s, 5s, and 10s are pretty easy because they've been skip counting by those. So it's just 5, 10, 15, 20, 25, 30, 35, 40.
I thought you stopped at 36.
I stopped at 36 on this one because 3 times 12 is 36. You go
okay.
to the factor times 12.
Oh, okay.
They basically list 12
Yeah, you
numbers
list
for each.
12 multiples for each. And then the 6, this is where 6s are a little bit harder to skip count by. So I told them go 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, times 4, times 5, times 6, times 7, times 8, times 9, times 10, and times 11, and so, yeah.
How often do they have to do this?
Every time they will want to make equivalent fractions, they're going to have to do this. If the question specifically asks for multiples, they're going to have to do this.
Okay, so you want them to write out this every time?
Pretty much, yeah. It's once they get really good at it, it doesn't take as long. It's going to take long the first couple of times. And a lot of the times when they're adding and subtracting fractions, they're only going to have to add and subtract 2 fractions, so they won't have to do 3 numbers. Some questions they're going to ask specifically for the multiples of 3 numbers, but I like them to get in the habit of looking at it, because another strategy that you can do is you can get a common multiple. If you just multiply all 3 numbers, it's not going to give you the least common multiple. And some of the kids, by the time we've worked with multiples for a little bit, they get really good at it and kind of look at it and tell that 30 is going to be the least common multiple. But I still want them to prove their work, because there's a lot of things like, there's a very common, I think it's like 3, 4, and 6, and a lot of kids will know that all those numbers go into 24, so they'll try 24, but it's actually 12, because they forget about that the 3 does go into 12, the 4 goes into 12. That's why I haven't actually listed them. So then what they have to do here, if they only have 2 numbers, they just look at what is matched in between those 2. If they have 3 numbers, so like I said, it becomes a tedious process in the reading, but then I can kind of zip through. So they say, do we have any 3s? We have a 6, but we don't have a 6 there, so they just keep listing until they see matches. There's 6 for those 2, but not the 5, so they can't circle that. So they keep going through, and then they see, when you get here, there's a 30, there's a 30, and a 30, and that's the smallest thing that is circled. If you were to extend the 3s out, they would also have a 60 in common, but that's pretty much just going to go with the least common multiple. They're only going to have to do least common multiple through 2s through 12s. Generally speaking, occasionally it will have them go to 15, but they can just repeatedly add 15. So the process at first does take a while and takes them a long time if they are not good with the multiplication facts, but then they get pretty good at it. And I have some kids would, like I said, can kind of look at it and figure it out, and it's just simply show me how you know that, and then they can move on from there. So that's pretty much how you find least common multiple. Okay, and then if it's asking for least common multiple, that's all they need to do. If they're looking for just all common multiples, then they would just need to circle all matches. You go back to the question. Alright. The other flip of the coin here is greatest common factor. So whereas with least common multiple, you're using the products from basic facts, with greatest common factor, you're using the divisor or the single digit numbers for the answers from the basic division fact. There's 2 different ways to find this. Both of them have their uses and their benefits from the other. The 2 methods that we call, the one's called the birthday cake method. That's not the official name for it, but that's just it's basically common factorization. We call birthday cake method because that makes it a little bit more fun. And the other way that we do it is the listing method, which, and again, they're going to have a maximum of 3 numbers there. So for the birthday cake method, they have to use the magic numbers, which are prime numbers. I just have them basically memorize the first 5 prime numbers. They sometimes need to remember 13 is also a prime or magic number. So I tell them first thing when they're finding greatest common factor, they need to just write down their magic numbers. Well, the biggest drawback with the birthday cake method, that's only going to give you the greatest common factor. It's not going to give you all the factors, which does run into a problem. I had students last year were really good with the birthday cake method, but then they'd run into a question that would ask about all the factors. And with the birthday cake method, you can only get the greatest common factor. You can't get all the factors. So that's why they need to also know the listing method, because that's going to give you both the greatest common factor and the common factor. Either way, whichever method you use birthday cake listed, the biggest match that they have is the greatest common factor, and the greatest common factor is used for simplifying fractions. So for the birthday cake method, what they do is if they are given 2 numbers here, they simply just write the numbers down. So I wrote 40 down there and I wrote 50 it. Then they also write the magic number. What they do is they just pull out the magic numbers until the magic number becomes the candle on the birthday cake. So from 40, they know they can pull a 2. They get 20. From 20, they know they can pull a 5. They get a 4. From 4, they know they can pull a 2 out. And then the candle on the top is the 2. So all they do is they write all the numbers on the outside and on the outside down like so. So 2 times 5 times 2 times 2. Over here they did the same concept with 50. They knew they could pull 5 out of 50. Lucky with 10, pull the 5 out of 10, and go up to 2. So 2 times 5 times 5. Then what they do, the fourth step, is just circle all the matches. So they have a 2 in common, they have a 5 in common. There's no 2 over here to match. There's no 2 over here to match, and there's no 5 over here to match. Biggest thing that I noticed last year was they would see there's a 2 and they wanted to just circle all the 2s, or they saw that there were 5 and they wanted to circle all the 5. Which then brings into the next thing. Basically, they have to know that even though they have a 2 circled there and a 2 circled there and a 5 circled there and a 5 circled there, they can only count it once. So basically, whatever circled in here, I told them that's what you multiply. So 2 times 5 is obviously 10, which would give you your greatest common factor for the birthday cake method. Like I said, it's not going to give you all the factors. It's going to be a quick way to do the greatest common factor. I really advocate for them to use the birthday cake method when they're simplifying fractions, because when you're simplifying fractions, you don't need all the factors. You only need the greatest common factor. So this would be the greatest common factor for the birthday cake method. What you do here, like the first step, is just write down the numbers, like so, and also write down the magic numbers to see who's paying attention. That's what the first 5 prime numbers were.
2, 3, 5, 7.
Good job, you did cool. 2, 3, 5, 7, and 11. Sometimes they need to remember 30. So what I tell them to do here is ask themselves which of those magic numbers can they pull out of 36. Anybody?
I'm afraid I say the wrong answer.
Okay. So 3 goes there, 12, and now they have to have themselves 12 a magic number, and it does not. So then they know they can pull something else. Now what can you pull out of 12? 2. 2. Which would give you 6. Is 6 a magic number? No, it's not. What can you pull out of 2? 2. Which would give you 3. Is 3 a magic number?
Yes.
Yes. So you stop there. Because the candle on the top of the cake is magic. So then all you do is you write that down. Doesn't matter what order you go in, eventually you're going to get all the same numbers down there. If I would have pulled 2 out, gotten 18, eventually it would have, the numbers would have been in a different order, but you would have ended up with the same numbers. So then you repeat the same process for 28. So what can I pull out of 28? 7. Very good. So 4 is 4 magic number. Now, so we pull 2 out. 2 is magic number, it's a candle. So then what you do, you go back, you look, you come over here. Is there 3 in common?
Nope.
No. Is there 2 in common?
Yes.
Yeah. Is there a second 2 in common?
Yes.
Good. Oh, that should be circled. Is there a 3 in common?
No.
Then you just got there's no 7. So then what you have is you have 4 2s circled, but you only really worry about small problem 1. So then 2 times 2 gives you 4. So your greatest common factor would be 4. There. Birthday cake method is going to be the quickest way for reducing fractions. As long as they remember they do need to circle all matches, but they only use half matches. Really.
That reminds me of that. Yeah, you started.
Yeah, when I started teaching last year, I had to kind of think back on some of this stuff. All right. The other method is the listing method. This is going to give you all the factors, not just the greatest common factor. So what they have to do is list the factor of the number. So they always have to start at 1 because all numbers are going to have the greatest, or not the greatest common factor. All numbers are going to have the factor of 1 because anything times itself or anything times 1 is always going to do that. So if your student ever tries to tell you they don't have the greatest common factor, they do because all of them have 1. Sometimes the greatest common factor is 1, that just means they can't reduce it. So they say, does 1 go into 12 evenly? Yes. So then they would write that down. Does 2 go into 12 evenly? Yes, they would write that down. Does 3 go into 12 evenly? Yes. And that goes 3 by 4. What I call this point is the wrapping point or the holding point, because 3 times 4 will give you 12. So that's kind of like if you would imagine the factors were written like this. 3 and 4 is where we basically mirror image. So then all they have to do is go back. So they know 3 and 4, they know 2 and 6, and then 12 and 1. So that's going to give them all the factors for that. So same thing here. Does what times? Will 1 times something give me 20? Obviously, yes. Will 2 times something give me 20? Yes. Will 4 times something give me 20? Yes. Will 5 times something give me 20? Yes. And there's their folding point because they know 4 and 5 are going to give you 1. So then they just start working backwards. What times 2 would have given me 20? So it goes there. What times 1 will give me 20? And then move to 20. The reason I included 64 here is because 64 is a perfect square, which means there's a folding point, which you have to kind of think about it. So they get to 8, and 8 times 8 is going to be 64. So you don't really have to write 2 8s, but you just need to know that it kind of pulls up on that. It's only going to work for a couple numbers. Basically, all the numbers that are going to be diagonal on a multiplication chart. Anything that like 5 times 5 is 25, 7 times 7 is 49. There's only a couple exceptions where they have to know that the folding point is going to be at that particular number. This is going to be hard for them if they can't quickly work with numbers because they know that they'll be able to know that they can pull a 2 out of 64 because it's an even number, but they might have to do a quick long division problem along the side to see what 2 divided by 64 divided by 2 will give you 32. Same thing with 4. They might be able to recognize that they can get a 4 out. They might not know off the top of their head that 4 times 16 is going to give you 64. I have one modeled on the smart board for this too. All right, so the numbers again are 36 and 28. Yes, well, what's always going to be the very first factor? 1. 1's always. So can you multiply something with 2 to give you 36?
Yes.
Yes. Can you multiply something with 3 to give you 36? Can you multiply something with 4 to give you 36? Can you multiply something with 6 to give you 36? What do we know about 6 and 36?
6.6.
Right, so there's our folding point right there, because that's a perfect square. So all we do is we go backwards now. So what times 4 is going to give me 36? 9. What times 3 is going to give me 36?
12.
What times 2 is going to give me 36? 18. And then what times 1 is going to give me 36? As long as they have matches, so these 2 match, these 2 match, these 2 match, these 2 match, and that's the folding point because it's a perfect square. They know that. That's kind of a way that they can check that they have all their numbers. So for 28, what's the first thing I'm going to write down?
1.
And I pull a 2 out of 28.
Yes.
And I pull a 3 out. No, so I skip that one. And I pull a 4 out. And I pull a 5 out.
No.
6?
Yes. No.
No. A 7?
Yes.
What do we know about 4 and 7?
That's the folding.
Okay, that's their folding point right there. So all you do is you start working backwards. What times 2 will give you 28? And then what times 1 will give you 28? So then if then you just circle the matches. Obviously they have 1 in common, they have a 2 in common, they have a 4 in common, and they don't have anything else in common. Because they're looking for the greatest common factor, this time it's going to be the biggest number they have in common versus the least common multiple. They have the smallest number common. That's a big sticking point because they will quickly learn to call them GCF and LCM just to save time. Sometimes they forget what the words actually mean and they try to remember when they want the biggest number, when they want the smallest number. So 4 would be your greatest common factor there, which is what we got down there. So you're going to get the greatest common factor. The listing method is going to give you all the factors. So if the question was, which of the following are factors of 30, 36, and 28, you're going to be able to tell 1, 2, and 4 are the factors of. The other person's only going to give you the greatest common factor.
Do you think it's going to confuse them to have the 2 different methods? Because I found in the time thing, there's multiple methods of doing things.
Yeah.
If you don't pick the right one, you could mess yourself up. That's why I found it hard.
Yeah, it can
And
mess them up. If they're going to master just one method, they need to master the listing method. The reason I teach them the 2 is because when we get into the reducing fractions, if they are reducing fractions, and they only know how to do the listing fraction for the listing method, they're gonna have to list every time. The birthday cake method, and there's multiple different ways to do it. It's the same concept as pulling out the prime numbers. That's gonna give you the greatest fun factor. It does have potential to confuse them, but the more they work on it and work on it at home, it's gonna kind of limit that confusion. I like to teach them a couple different methods, but there's a rationale behind why they need to know both. All right, so common mistakes are not choosing the right one if they're supposed to be doing the greatest common factor thing or the least common multiple. A lot of times, I forget what my class came up with last year about how to remember. But basically, if it's asking for factor or multiple in a question, that's going to be really easy. They just also need to remember that when they are working with making a fraction smaller, they need to use the factors. When they're working with equivalent fractions, they need to use the multiples. As we go through it, it gets a little bit more ingrained in their mind, so it's going to make it a little bit easier. Not knowing the basic facts is going to be a huge problem here, because listing all those numbers and listing out the multiples, if they don't know their basic facts off the top of their head, you tell a problem to them and they don't know it, that's going to slow them down a lot, and they're going to get frustrated and they're not going to want to do it. They won't even get to the point where they can reduce the fraction or add the fraction because they're so slow with or frustrated from getting the basic facts. They really, I can't stress enough how much they really need to know their basic facts. At this point in fourth grade, they really need to know all their multiplication facts and division facts at the drop of a hat. Other thing is not extending the multiples far enough. Like I had said before, I always try to have them extend to 12. Some students just simply don't want to extend them out to 12, and we'll just stop when they find a match and not all the matches, which goes with the next thing. They will sometimes find a match, but not the least match. For instance, for 3, 6, and 2, or 3, 4, and 6, they know that 24 is a match, but they might not know the 3 is a match, or 12 is a match. So they might find a thing, or not circling all the common factors, including the 1. 1 is something that they are so easy to overlook, and they're going to miss it all. So these are 2 ways that they're going to see on the SOLs. First one is, it says identify the numbers that are common factors of 16 and 24. That's where they're going to have to do the listing method, because they're going to have to write 16, 24, and find their folding point, and then they would have to identify all. They need to get in the habit that as for factors, you're always going to select one, no matter what. So that one, they would have to pick whatever the common factors are. And then which one is a multiple of both 8 and 9? They included 1 as a factor there because the students will know that 1 is always a common factor, but 1 is hurting you unless the numbers are 1 and 1. 1 is never going to be a multiple of those 2 numbers, because the only thing you can get a multiple of 1 is 1 times 1. So they would have to do all the listing method there. We really only do listing method for multiples, because that's the easiest way to do that. So greatest common factor will lead directly into reducing or simplifying fractions. Basically, all that means is it's going to give you a bigger fraction like 20/36, and you want to get that in the smallest terms. It's kind of easier to understand what 5/9 is better than 20/36, because to me that's kind of hard to figure out what exactly it means. So all they do is they find the greatest common factor of the numerator and denominator. This is where they would use the birthday cake method, because that's going to be the most efficient and fastest way to get the greatest common factor. If for whatever reason they struggle with the birthday cake method, they always do have the listing method to fall back on, which is going to take a little bit more time, but you will eventually get it. So when you do it like that, you will get 4 as the greatest common factor. That seems to be a repeating thing today. So then after they find the greatest common factor, they need to divide the top by the bottom. What I always say to my class last year was, if you're dividing with fractions, before you do the top, you must do the bottom. Because technically speaking, dividing 4 by 4 is dividing by 1. You can multiply anything by 1 and divide anything by 1. It's just going to get equivalent things. It's not going to change the actual value. Then when you multiply the top by 4, that's going to change the value. If they multiply the denominator by 4, that's going to change the value. So I would say to them last year, I would say whatever you do to the top, and then I point to them and say you have to do to the bottom. Or I reverse it, and I'd say whatever you do to the bottom, you must do to the top, just to try to get that engraved in their head. They did pretty well at remembering that. So then what they have to do is they divide across, like how we think of it as 2 different basic fact problems. 20 divided by 4 is 5, 36 divided by 4 is 9. If they get the greatest common factor and they did it properly, that's pretty much the last step. Some students will know that 20 and 4 you can pull a 2 out of, so they'll have to do a couple steps. I try to get them to just find the greatest common factor right off the bat because it simplifies the steps in the long run. So if the top is 1, or the denominator is magic number, or the numerator can't go into the denominator, they know they're done. But if they would only pull 2 out and was 10 18th, they know that they're both even numbers. You can't have an even number on the numerator and an even number on the denominator for that to make sense. That's one thing that they struggle with, which is why I'm introducing simplifying fractions before we do anything else with fractions, is because when they're adding subtraction fractions, they might end up with an answer of 2036. And I know SOL is going to say, you need to put an answer in simplest terms. So while 2036 is technically speaking correct, they will ask specifically for in simplest terms, so they need to remember to always check if they can reduce that fraction. All right, so I put 1 here. So what we're going to have to do is do the greatest common factor of 15 and 36. We're going to use the birthday cake method because that's going to be the fastest way to get the greatest common factor. So what's my magic numbers again?
2, 3, 7, 9.
5 also. All right, so can I pull any of the magic numbers out of 15?
1, 3.
Yep, you can pull 3 out. And it's 5 a magic number?
Yes.
Yes. So we're done there. Can I pull any of the magic numbers out of 63? 3. Thank you. And that gives me 31. Which then they would have to go, 31 is a prime number, so you can't pull anything out of that. But they would have to ask themselves, can I pull it out of 3, 5, 7, 11? So that's why they have the first 5. They don't need to know all the prime numbers because they'll just be one more thing on that. So then they just have to write these down. And they have a 3 in common, but not that. So 3 is your greatest common factor because you have only a 3 sign out of it. So then what they do here is they divide 3 and whatever you do to the top.
15 to the bottom.
All right, so 15 divided by 3 is 5. 63 divided by 3 is 31. You can't put a 5 into a 31 and you can't get reverse, and they're also both prime numbers or magic numbers. So they know it's most reduced there. It seems like it's not most reduced because 31 is a larger denominator than they'll be used to seeing, but that is most simplified. All right, so ways to practice.
Sorry.
Ways to practice is going to be IXL Q.8. That one specifically is going to do reducing fractions. Another thing, we do this with long division. There's just a little thing called power towers. And all you do is you get Dixie cups and you write fractions, unsimplified fractions on the outside, and then you write the simplified fractions on the inside. We did this with division factor this week. My kids really liked it. Some of the students actually wanted to do the division 1 during indoor recess rather than doing games, so I was okay with that. It will require some prep work. It took me probably about an hour to make 2 cans worth. Alternatively, my girlfriend took her all day to make these for me, but it only took me an hour to make them. So then what they do is they see 12/60th, they have to do working paper, and they'll reduce it to 1/5. If they get it right, which the answer is inside, so it's self-correcting, they get to keep it. So then they have to keep reducing. They like to make towers because they can go, when the whole tower's done, they just box them all up to start again. They were doing it as a competition today with this. I will tell you, it will take a long time to make these. It's going to pay off because you only have to make them once. They're all going to need to know how to reduce fractions for the rest of their schooling. So it's just a quick, easy way, and a nice Pringles can, just so it's convenient. Another thing to practice that, I don't have this listed, but I just made this the other day. You just get one of these cheap puzzles you can get from the dollar store, and what you do is you take the, is this a great calculator? You take the puzzle piece and you write 2 numbers on it, and then whatever, so 14 and 25, and what grades common factor is that? No, that wasn't. That's bad. Whatever the answer happens to be, it's 1. because I just made a big point of saying that the greatest common factor is always 1, and I forget. 14 and 25 have nothing in common other than 1. So then I wrote on the puzzle piece 1, so then they put it there. It's self-correcting, eventually they'll make the puzzle. This takes a lot less time to make than those, especially because there's this really cool website called Greatest Common Factor Calculator, where you just type in 2 numbers and it will give you the greatest common factor. Don't tell your students quite yet. But that's what I used to make these. This took me significantly less time to make than the Kernel scans. Another thing you can do is just take number tiles and just number them from 2 to 144 and just throw 2 tiles at them. Don't physically do that. Yeah, go on. Put 2 numbers, 2 tiles, and just have them simplify whatever 2 tiles pop up there. So that's basically different ways to practice reducing fractions. Just trying to make it a little bit more fun rather than just color fractions to reduce. Can you go back? I apparently left out the slide. There should be a slide in there that says common mistakes. Pretty much common mistake is not reducing the fraction when we need to reduce the fraction, or not reducing it far enough. Okay.
I thought it was in there. Yep.
All right. So for the SOL questions for fractions, for at least this part of the fractions, they're going to be pretty straightforward. They're not going to try to trick them too much. Like the division statement will try to trick in that sense. These are going to be a little more straightforward than the word problems with multiplication and division and addition and subtraction, because it's not having to do multi-step. When we get into computation with fractions next time, those ones will get a little bit more easy. But like I said, adding subtracting will have the word problems. But this part of the thing is more about the ability to reduce fractions by the greatest common factor. It's going to be pretty straightforward questions. It's going to ask them for the common factors, and ask them for the common multiples. It's not going to put a big book and then the last thing at the very end is what's the common factors. It's going to be pretty straightforward. So that's one silver lining of this. All right, the last part of the thing I want to do this evening with you is go to IXL and just kind of really work through how to get on IXL, how to explore IXL, how to make sure your child is doing what they're supposed to be doing on IXL. Sometimes students, I'll tell them to go on IXL at home, and the student will say, I went on IXL last night, and I said, well, according to my teacher account, you did not, because I can see exactly how long the students stayed on, how many problems they did, what answer. I can see, other than seeing into your house, I can basically see everything that I would need to know from IXL.
This is why she tapes up her camera.
I wouldn't do that, but I can see it's funny. The one time before the students knew that I could see who went on, I had them say, I was like, raise your hand if you went on IXL last night. And I'll say like half the class put their hands up. So I just typed in some things on Smartboard. I was like, well, actually none of you did. So, and I told the students over this past weekend, I said, I try to get them to go on IXL because that's going to be the easiest way for them to practice these math skills, because it's going to walk them through that. I said, whoever goes on IXL the most over the weekend will get some sort of special prize. The student who had gone on most for the whole Friday night, Saturday, and Sunday was a total of 9 minutes. So I was like, 9 minutes isn't going to get you a special prize. But IXL is really going to be a really good way to them, because it's going, if they make a mistake on IXL, it's going to talk them through exactly what they went wrong, as long as they actually read that. So I'm going to actually have you log on to IXL as your child. So you need to click on the link that says IXL.com. And then,
Where is
yeah, in the presentation, it says IXL. So your child's username is their first name and last name, and then 471. Clara's, it's just Clara Reyes, 471. I think everybody else's is full name. And then everybody's password is HJB1. And then you can press enter. So when you successfully entered, it's going to bring you to a screen that says, welcome, whoever child is. This is Gracie Berg. A couple of things I want to run you through here is, first thing I want, as a parent would be helpful to do, is click on the thing that says Virginia SOL. Stop moving on.
Oh, sorry.
So for Virginia SOL, it's going to take all of our SOLs and it's gonna tell them what things they need to work on. So if you know if they're struggling with rounding decimals to the nearest whole number, that's gonna take you right to U12. So that's just gonna tell you if you know the specific things that they're working on. That's gonna be very helpful because on the top of all of our tests, it always lists the SOL numbers. So you can just kind of match up those numbers with this. The other thing that's going to be helpful for you as a parent is to press reports. And it's going to give you all these different reports. I have a much larger version of reports as the teacher account, but as the parent, you can see, so for instance, Gracie, this is just the overview. Gracie has attempted over 3,000 problems at this school year. She's practiced 62 different skills. She's spent 17 hours on this. She's earned 52 medals. So that's going to give you an overview. Then this is going to break down. The usage one is the one you really want to look at, because when you click on usage and usage log,
How much should it be, the usage log
how overall or per day?
per day?
I would like for them to get on for 20 minutes a night. So they need to be practicing whatever skill.
So even if you're on it 20 minutes and don't finish that skills, can you see that?
Yep.
For example, there was a day last week, I think, she didn't quite finish it, I mean, it was late, and we just said, well,
Yeah, it's going to show me how much time she actually spent working. So that's one thing. We were in a countywide committee meeting. They said, well, what's to stop the kid from getting on at 6, going play Xbox, come back at 7 and logging out? It's only going to show me the time that they spent working. So that means like reading the problem, basically when the mouse is moving or they're typing something in. So yeah, I can see how much time they spent practicing, how many they did. If they spend 20 minutes, and did like 63 problems, that basically tells me that they only did basic multiplication practice, where they didn't really put their effort into it. Generally speaking, 20 minutes, they should be able to get about anywhere between 5 to 10 long division problems done, depending on their ability level. But yeah,
So is it torture when you don't, just the whole block in one day?
that's a bit much.
I mean, I feel like you started, you might as well knock it down.
Yeah, it depends. That's depending what. Yeah.
there was one that she was there.
And the thing is, and then they can get to a certain point, and then if they miss one, it
I
backs
think that's
them
what
up.
happens. Maybe
Yeah.
she'll get to 95.
Well, I tell them not to worry about whatever the score says, just to worry about like
And not always mastery.
The most important thing is we're doing this.
the thing I was trying to show you is, I guess it's actually skills to practice. Is what I want to do. Like I said, my teacher one looks different. One of these reports, you kind of got to play with it to see. It'll show you what they worked on. So if you tell them to go on IXL for long division, and you go and you check, and they actually did multiplication facts, that's what a lot of students, and I'm okay with them practicing multiplication facts here and there, especially if they need work, that's what they need to be working on. But if they have a long division test coming up and they spend their whole time on IXL just practicing multiplication facts, that's not very helpful. But I will, but
And I'm so happy I can check on that.
yeah. So the last thing I want to point out about IXL is it is based on pretty much the progression of skills. So the very first thing is obviously number sense, and then it goes through all the basic skills. You just kind of look through. The letters don't necessarily always go with whatever the skill is, but it just kind of goes in a continuum. But if your student's struggling with their basic facts in the division, in the multiplication, it's D1. Pretty much for all the computations, addition, subtraction, multiplication, division, whatever the letter 1 is going to be their division fact or their basic facts. That's going to basically do automated flashcards for them. For instance, we're just going to click on that. So that's just multiplication facts. It's just going to give them their multiplication facts and then type them in. Gracie has 2 medals in them, so she.
And this is where?
If you go to, I kind of skipped this up, I guess. So we were just reports. You click up here on math, and then you just click on 4th grade, and then you can do whatever grade. I prefer 4th grade or higher, not any really lower than 4th grade. And then it's just all sorts of things. But if you do the up from the top, the Virginia SOL thing, that's going to give it a line to the SOLs, and then they can work on specifically, because the IXL has more than we need for the as well as it's aligned to Common Core. Common Core has some stuff that we don't. We have some stuff that Common Core doesn't. But this crosses over pretty well. Another cool thing about IXL is there is also a language arts component that's going to cover more grammar skills and comprehension. They're working on the comprehension stuff. But if your student's struggling with prefixes, suffixes, homophones, synonyms, antonyms, anything like that, any pretty much grammar skills versus cause and effect or sequencing, the language arts is going to help them with that. They are supposedly working on comprehension, but it has not shown up quite yet. I believe it's the last one I checked. And yeah, it's all there. So it does have language arts and math. We use it mainly for math, but occasionally we will use it for language arts. So that, can you go back to the presentation? Return full screen. Okay. So that pretty much concludes our evening. I ran a little bit over, I apologize. Again, thank you for coming. I really do appreciate you coming. Really, you need to make sure you're using these strategies with your child at home because it doesn't really help them much if you come here and listen. Your sport's really going to make the difference. This will definitely be a very interesting thing. Everyone else can accomplish tomorrow. We're working on one front. It'll be interesting to see. I'm going to give them a pre-test for their things on fractions on Thursday or Friday, and it'll be interesting to see their post-test how much the students whose parents here grow in comparison to the students whose parents did not. So it'll just be an interesting thing to see really how much your input does. The last thing I want you to do, if you wouldn't mind, is back in the presentation. If you click one more time, the feedback slip is the feedback slip is the last thing I'd like for you to do. That just kind of gives me a little bit of information of what to do. But is there any questions? If there's no questions, we'll stop the recording so you can do the thing. Okay. Can you stop the recording?
Yeah.
It's on the